Today we're going to use what we've learned about logarithms with some of the compound interest formulas that we learned earlier. Sorry, you can't really see everything on this slide. At the bottom of this, it says t equals number of years. So below where the screen is, it says t equals number of years down below. Here's the formula we used for compound interest. N is the number of times it's compounded. So if it says monthly, N is 12. If it says quarterly, N is 4. If it says daily, N is 365. Compounded continuously uses the PERT formula. Remember, E is that number in our calculator, that button over the LN button. Determine the time necessary for $10,000 to double if it's invested at an interest rate of 8.75% compounded continuously. If you see the word continuously, you know immediately that it is the PERT formula. So let's plug in what we know. We are starting with $10,000 times E raised to the rate. How do we do 8.75% as a decimal? 0.0875 and then T. And normally we do equals the total amount over here. I'm actually going to move that equals A over to the other side. It will be easier to solve this with how we've been doing logs if your equals the number is over on the right. So we want this to end up equaling, what is double 10,000? 20,000. Okay, what do we need to do first? Divide by 10,000. And we end up with E to the 0.0875t equaling 2. I want to draw your attention to this 2. We did our ending amount divided by our starting amount and got 2 because we're trying to double the amount. So if I had started with $1,000 and had this be $2,000, this would still be 2. If I had started with $500 and wanted to end with $1,000, this would still be 2. So that is something worth noting for your assignment, that if you're doing your starting amount times E to the RT equals your ending amount, and you want your ending amount to be double, the next step is going to be E raised to the rate times time equals 2. So that might be a little shortcut for your assignment, just saying. Okay, what do we need to do to solve from here on out? We're stuck. We need to change forms. So 1, 2, 3, woo! We need log base E of 2 equals 0.0875t. What is log base E the same as? ln. So I could erase log base E and replace it with ln. ln of 2, you can punch that into your calculator. So grab your handy dandy calculator. ln of 2 is 0.6931. What do we need to do to get t completely by itself? Divide by 0.0875. Whoa. So 0.6931 divided by 0.0875. Did you get about 7.9? Yep. And now let's go back to the question. Determine the time necessary. The time is 7.9 years. Please don't forget about your label. Determine the time necessary for $1,000 to double if it's invested at an interest rate of 9.5% compounded monthly. If it's compounded monthly, it is this formula. N is how often it's compounded. So monthly means that N is 12. And for ease, I want to put equals A on the right side instead of A equals on the left side. It just makes it easier to solve. So we are starting with $1,000 times 1 plus 9.5%, 0.95 over 12 raised to the 12t, and we need this to equal $2,000. If you're doing problems like this where it's asking you how long does it take for something to double, you really don't need the p and the a, because your first step is going to be to divide both sides by 1,000, and 2,000 divided by 1,000 is 2. So all you really need in this formula, if you're doing the doubling problem, is the stuff raised to the exponent, and then on the other side it'd be equals 2 because you're trying to make your amount double. All right. Now, I don't really like this because we're going to have to estimate what this decimal is. So put the stuff in the parentheses in your calculator. 1 plus 0.095 divided by 12. It is 1.0079 raised to the 12t. Okay, we're stuck. 12t is in the exponent. We don't want it to be in the exponent. You can't divide by 12t to make it come out of the exponent. You can't do anything crazy. The only thing you can do to get something out of an exponent is to change forms. So, 1, 2, 3. Woo! That was a very non-enthusiastic woo over there. I'm quite disappointed. Log. We write the base first, 1.0079. The next number we write is the 2 equals 12t. If you have a fancy schmancy calculator, you type in alpha window 5, and then you can type in that 1.0097 or 79, whatever the order is, and the 2. Otherwise, you do log button 2 divided by log button 1.0079. Either way, 1.0079. I got 88.086 equals 12t. What do we need to do for this last step to figure out what t is? Divide by 12. I got 7.34. 7.34 years, or 7.3 years, or however you round it. I'd like to call these real world problems, but let's be honest. If you're investing money, you're not going to get a 9.5% interest rate. It's just not going to happen. So these aren't really real world, but whatever. On your assignment, I've changed it from your assignment sheet. Instead of 31 through 34, you're just going to do numbers 31 and 32. So 4 problems. On number 4 and number 6, they don't give you a principal amount. So if you ignore the P in the formula, you can just put it equal to 2 because they're asking you how long is it going to take for your principal to double. Or if you want to, you can use a principal of 100 or 1,000 or whatever easy number you can think of that you want to use. So if you feel like you need a principal for 4 through 6, use something like 1,000. And you can just write in your notes or in your assignment like I used P equals whatever.